Alright, here we are. So Mr. Day wanted me to play with the FET and build a series circuit. So here's my battery. And I can put multiple batteries here. Connect them head to tail. And it looks like I can take a wire. And now I'll put a light bulb. And I'll put another wire. And let's see here, maybe I'll put it like in this shape, make a nice square so it's simple to understand. Another wire. This is a great FET. I mean, it's just nice to be able to play with a circuit and get instant feedback as to how the bulbs will light. And especially to predict, like I'm guessing both bulbs are going to light because I have a closed loop with both bulbs. And there we go. So this is a series circuit because there's one pathway for the charge to go. The only thing I don't like is it's showing the flow of electrons and not showing conventional current. Because current is actually going around the loop the other way.
I always tell the kids that it would seem as if...
Speak loud, because then I can hear you.
So we understand that the electrons are going to go from the negative to the positive, but it would seem like every time an electron moves, you would subtract the negative. So a positive would appear to go in the opposite direction. That's a negative. So that's the way I explain it.
Yeah, it's the same thing. I do that. I say that too.
I have a bead, set of beads, these big Mardi Gras beads, and they have symbols on them, so that when they move, you pull and you're causing them to move.
Yeah, that's cool. I'm just playing with the FET now and seeing. So I'm changing from schematic symbols to lifelike. I can measure the current with an ammeter. That's a special meter to measure current because current is measured in amps. So let's detach here.
Why do you have to have it running through there?
Well, how are you gonna, that would be good to explain, is the current has to go through our ammeter because that's what it's measuring. But the question is, how does an ammeter not change the flow of current? What does that tell you about the resistance of the ammeter?
Your resistance has got to be very, very low.
Yeah.
I mean, it's impossible to have no resistance.
Right.
But you can limit the resistance by using different materials.
Right. Because if this had a high resistance, it would decrease this number that it's trying to measure. Crazy. Now, voltmeter is completely different. We're going to measure the difference in charge pressure, the difference in voltage, the difference in energy per charge. There's a lot of ways you could look at that. Now, if we're talking 27 volts from the bottom of the batteries to the top, that must be like 3 9-volt batteries? No, I can't. Yeah, 3 times 9 is 27.
Yeah.
Okay. So
what you're saying is at the positive end it should be 27 volts, but at the negative end it should be 0 volts.
yeah.
And as you go through the closed loop, you should have 0 potential or 0 volts as well.
So what will the drop be across this bulb, and the voltage drop across this bulb? Because the batteries are a rise in voltage across the batteries from negative to positive, but due to the resistance of a light bulb, energy is leaving our circuit, right? So we've got a drop in energy per charge across the bulb. So if I go here, let's see how much our drop is. So that's halfway. We've dropped halfway. So whatever the voltage is here, we drop halfway because we need to drop again. So the difference in voltage has got to be the same. The potential difference, the differential voltage, all that means the same thing, is the same across both bulbs.
That's if they're the same resistance.
Good.
Because the same current's going through.
Yeah.
The same value of current is going through. The value of the current didn't change, but the voltage did change. Some voltage was used to push the current through that resistance.
Right.
And since these resistances are the same, and therefore they should have the same voltage drop across the bulb.
Cool.
However, what you're seeing here is a theoretical system where the wires themselves have no resistance.
Right.
Otherwise, you wouldn't have that.
Now, why don't we see the bulbs lighting right now? That's I'm kind of
You
wondering.
asked for that.
How do I get it to do that again? And look, if we switch the red and the black, we get a negative value. So the red's supposed to be the high voltage.
Right. And as you go around the loop, you go from the positive end of the battery to the positive end of the light bulb to the negative side of the light bulb on the other side.
Okay.
Right? So they're showing you a drop. If you're going in the opposite direction, you should have a different voltage.
That is so cool. Anyway, that's series circuit, simple series circuit. This is good in a sense that it shows that the current is the same everywhere. I mean, we could put this ammeter anywhere in the circuit and we're going to have the same current. Hope that helps you understand basic series circuit.